Hello? How are things? Alrighty. It is about that time. Oof. Aha! Alright, let's see who's all here. We have a handful of you plus some bots. Cool beans. Tried making a singleton in Python. It works okay. You just have to implement it correctly. I'm actually going to do an example in class today, so. Hopefully later on, when we get into it a little bit, if anything pops up that you had problems with, we can chat about it. So, what we're going to do today. Okay. Turning off notifications. So what we're going to do today is we're going to get through some design pattern stuff. And I'm stuck between C, Python for Northern Leaf. Nice. Hey, that's the nice thing about programming is if you learn one, you pretty much can transition. It's just the syntax for it all. I'm going to be doing everything in Python in here. Your term project might be in Java, I suppose, but at least software engineering is fairly language agnostic. It's kind of one of the things I like about it. But good luck. That's a lot to have on your plate. Alrighty, so Wednesday and Friday we will have our midterms. After class, sometime this afternoon, I'll send out an announcement with all the information you need to know about joining. As a reminder, it will be on Blackboard Collaborate instead of Twitch, so don't come to the Twitch stream on Wednesday. There won't be anybody here. It'll be dead air. But if anybody has any questions on the term project, please let me know. Do you prefer high or low level? That's a good question. It depends on what you want to do. So if you're doing something that is at the hardware level, you're probably going to want something a little bit more lower level. So like if I'm writing a controller for a particular component, it's probably going to be very low level. C might be as high as you get, but more than likely you'll probably be setting registers. High level, I tend to like things, it's dependent on what I'm doing, I guess. So my little game that I'm thinking around with, it's in Python. If I wanted to release it and make it nice and performant, I'd probably redo everything in C, C++, maybe learn Rust, but I don't care about memory management enough where I'm at to make Python a concern. Like if I'm making a real game, for instance, I want something where I can access the GPU. I want something where threading is a lot more intelligently put together. If I don't care about that stuff, I'll go something super high level like Python or, Java or C++, depend, well, not C++, but C++ with all the extra stuff like Boost and the, C99 or whatever we're at now. It just depends. It depends on your application. I recently acquired an Arduino for the first time. I've been Raspberry Pi lover forever. And I tried an Arduino and it was just so easy to do stuff. And it's in almost like a variant of C, it feels like. So I don't know how I feel about that. I feel like I should be setting register values, not calling write signal. Things are easy. Anyway, if that's something you ever want to chat about, though, we can definitely do it outside of class. But the long story short is pick the language that makes the most sense, I would say. So, as a reminder, on the 30th, you have 3 separate things due. So make sure you don't forget about them. You have your slides, which have to be posted by the 30th. And then you have the 2 aspects to homework 4. And again, those are in UML and design patterns, and then homework 4 individual, which is just to make sure that you're all keeping up with the material and that you're not just kind of glossing over it. You're actually thinking about why we use some of this stuff. And then the homework 4 group work, this is your task stuff that you had to do. So your project planning and charting and all of that fun stuff. So just make sure you get all of that in, and we will have a in-class assignment today as well. It was much better. Okay, that's interesting. I honestly would have thought it would have been easier keeping it together, but I figured I'd give this a shot. It's going to make grading a lot easier, I can tell you that much. So we'll see how it plays out. Make sure everybody else is in that same boat. The whole having to grade online thing is a new and interesting aspect. I mean, obviously I had to do it before, but now it seems even crazier with everything going on. So yeah, you got those three things. Midterms are Wednesday and Friday, and for Wednesday and Friday, all we will be doing is the midterms. So don't bail out. I'll ask you for feedback on everybody's presentations. Like I'm not gonna, just don't just pop in for yours and then you're done. I'd like to actually to listen to other people's talks and give them feedback. I'll give you a little sheet to fill out for that too. But there won't be any like content from me. It'll be just all focused on you all. So I'm looking forward to hearing what you all have to say. All right, other than that, we should probably crack on because otherwise we're going to fall behind. So last time I ended right around here, actually here, but we were talking about the different types of design patterns, right? So there were the creational side, which focus on the how you like instantiate classes, how you create them. You know, obviously it's in the name, right? Creational. So we've got a handful of these. We also talked about structural. These are the static components of your projects, how things are kind of put together in a way. And then your behavioral as well. And these are going to be your dynamically focused ones, right? Algorithmic based or expressed behaviors, things of that nature. We're going to talk about three in these set of slides. Next time we'll talk about the visitor pattern a bit. And I will say that the patterns we're going to talk about in these slides, we're not going to get to them all today, but these are very easy to implement more or less. And if you tried doing a singleton on your own and you struggled, that's the easy stuff. The harder ones are, honestly, they get into the behavioral side. Like observers, even not really all that bad. But when you start talking about things like visitor, there's a lot more complexity going on. So with these patterns that we have, we're going to start actually talking about them now. So that's probably the easiest way to describe them. So let's start with singleton. Now, singleton is honestly pretty straightforward if you need something that you only ever want one instance of, right? So this is creational, deals with instantiation, right? Deals with creation of objects. And the thing with singleton is you only want one instance of that. And what that means is that, let's say you create a class, and I'm going to use random number generator because that's a nice, easy example, but you could use anything where you want one reference point, basically. You will instantiate it once, and then anytime you need to access it later on, you would get a reference to that instance. And the benefit there is that you only have one little blob of memory for that particular instance that you've created, right? You're not going to create 100 of the same thing and keep that all in memory. You only have one. You could consider that to be useful from a data management perspective, right? There's only ever one of this set of data. Or it could be a memory overhead type of thing where you only have one coin, for instance, and references to that coin are basically referenced all over the place. I guess let me talk about this in terms of the random number generator. So if you're making like a game or you're doing any kind of statistical analysis or some kind of mathematics that involves random numbers, I'm going to use game because that's a nice, easy to visualize example. When you create a random number in any programming language, and hopefully you know all by now that it's not actually random, right? It's called pseudo-random. When you want us to submit our commit ID, what is that exactly? So let's talk about that for a second. Commit ID is when you push your data to GitHub, you'll get a commit ID. Right, so let me show this very quickly because this is not the first question I've had for that one. Do you import the singleton? Let me handle the commit first, and then we'll get back to singleton. So when you look at your commit log, you'll see your commit ID. Basically, that is the point in time for here. So here I get a simple, is this copy? I think that's copy. So you get like a big long string of numbers. But when you commit something, you get a commit ID, and you can look it up in GitHub pretty easily. All right, so to your other question there, basically what you do with singleton and I'm going to show you how to do this in Python and Java really quickly here. But you create one instance and then you reference that instance everywhere else. So basically, you only instantiate it one time. I was able to get it such that when I instantiated in two different places, had the same object ID, but the data was not the same. That is interesting. That might be something for you to share offline, perhaps, and I can take a look at it. All right, so two singleton and random number generation. So I'm sure many of you have played games where there's randomly generated content, right? And you can add a seed when you start out so that you always get the same game or the game that you want, right? Like Binding of Isaac, put in a seed, you get these particular items. Or Minecraft, you get a particular world generation. Terraria has it. Basically, any game with random generation and they have a seed, that's basically seeding the random function. Now, if you have one random number generator that controls the entire thing, putting a seed in will cause it to always generate the same random number distribution. Whereas if you split up your RNG and every function has its own random number generator, then if you put in that seed, you have no idea what's going to happen because they're all creating their own set of random numbers. And maybe that's what you want. However, most games or most applications with randomness, you want it to be repeatable. So you have one random number generator and only ever one. And then you can always be sure of that distribution of numbers. So with a singleton, if you turn, say, your RNG into a singleton, you create your random number distribution, and there's only ever one instance of that. And you would reference that whenever you need to call like random.getInt or whatever your language of choice is, random.randrange if you're going in Python. So basically what's happening here is that the class is instantiating itself, and you can only ever have one instance of that. Right, so how do we do this? We have a private static member that basically refers to the object. So you have class singleton, private static instance, or something like that. And that instance is the reference to the instantiation of the class. Then you have a public static method, which is basically going to instantiate the class if it doesn't exist. And if it does exist, return that instance. So again, it can only ever be instantiated one time. Now the constructor should be private or protected, and this goes to that data hiding aspect, right? Where we're going to rely on the object-oriented side of things to help us out with these design patterns. Basically, you're going to set up your data hiding principle such that nobody else can ever instantiate the class by themselves. And why would you do this? It's not always just going to be you creating a project, right? You may have other people adding modules, and they're going to say, oh, there's a singleton class, let me instantiate something. Well, no, you would have protection in there so that nobody else can do that, for instance, or so that 20 minutes from now version of you doesn't accidentally try to do this as well, right? You'll get basically an assertion error, or you'll silently fail or something like that. So we have that aspect here. Now, pretty straightforward implementation. We get very, 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 very controlled access to this instance. And let me just kind of pop over to the UML diagram here to show you what this actually looks like. So here is your class diagram. Here we have a member variable or an attribute where this is your private static singleton. We have our constructor, again, private or protected, and then we have a public get instance function. Basically, the only thing that external users can do, or external classes, is call get instance for this particular pattern. All right, so here is where things go a little bit wonky. I know that you all had Java coming into this class, so I'm going to assume that you at least know Java. Last time I made no qualms with showing that I am not a huge fan of Java. And rather than me screw around and have a million Java errors because I'm not an expert at it, I'm going to do all my live coding in Python, but I will show you the Java code for how to do this. So hopefully I'll give you the best of both worlds. And I'm going to have links in here as well, or there are links in there. The links to the Python tutorials tend to link to C as well. Like, so you can have a C++ singleton. It's just like a couple of link follows to get there, basically. But again, these are going to be valid in pretty much any language. So here is the Java class for the singleton. So it's a public class, right? So we can reference it anywhere. Inside, here's that private static instance variable. So basically, this is going to hold the instance of the singleton. We have a private constructor that nobody else can call. And then we have our public get instance function, and that's really all there is to singleton. So let's say that somebody else wants a instance of singleton. They would call singleton.getInstance. Now, if that's null, meaning we've never created this before, let's create an instance. And again, it's internal and private, so the only person who can ever see this is the class itself. And regardless if you created it or somebody else did, you'll get that instance that was created. All right, so hopefully fairly straightforward. And every language will have its own particular inflection of this. Like I said, I'll do it in Python. It's going to look a little bit different, but the ideas are going to be the same. All right, so that's your basic class. You can also make it protected. So I swapped slides, private or protected. They will both be valid. So the point is that the constructor is hidden from other external classes. Hopefully you remember from your last, your Java classes, private and protected, what's the difference? With both of them, whatever you have made private or protected cannot be accessed or viewed outside of the class. All right, so when I go back here, the only thing that can ever see this constructor or this variable here is anything inside of the singleton class itself. So if I want to add 30 more functions inside of this class, they can all see instance or the constructor. But once I go to my normal program, nothing can touch it. All they will ever see is this get instance function. So that's private and protected. The difference in why we have two different ones is that if you have a child class or a derived class, they can see those variables or those methods, whatever you've called protected. But typically there's going to be a reason why you're deriving, right? Or why you're making a child class. It needs to know what is in the parent class and be able to access it. So minor difference, but they're still hidden from the outside world. And then just to round it out, public you can access from anywhere, right? So if you have one Java package program, anything could access a public attribute or method. So just a little refresher on private versus protected. So to go back to our example here, now this is a JUnit test. You could put this anywhere in a Java program. It doesn't have to be in like a JUnit fixture type of thing. But that's the little decorator here in void test. Basically, if you ran a Java unit or a JUnit test framework or test harness, it would just call the test function. But here, what we're doing, we're going to extend singleton and create two classes here. So singleton child 1, singleton child 2, extend singleton. So basically, we're going to create two new classes internal here, and we're going to see if they're equal or not. All right, so singleton child 1, singleton child 2, and then we're going to call get instance. So basically what we're going to do here is we're going to get a reference to that particular singleton instance. And to make it a test, we're going to see, are these two objects the same? If they're different, it would return false. Our assertion would trip, and we would get a big error. But what's happening here, if this is the first time that we've ever called get instance, the singleton instance would get instantiated here and then set. And then in this particular call, we just get the reference. All right, so they're going to be the same object, basically. Same blob of memory. Does that make sense, I hope? So again, very, very simplistic way to handle something where you only ever need one memory space to deal with. Now, I did some searching on the internet after my last class because honestly, I wasn't sure. I had a pretty good feeling, but it seems like the internet's kind of split on this. So you can only ever have one instance of this class. right? So that point's clear. This object never changes. However, there is a lot of debate on whether you can dynamically update the internal values. So for instance, if you read like a configuration file, or this was a network parameters kind of thing, there's a chance that the internal variables here would change. Right, so one of the examples that I kind of glossed over earlier, let's say that you're making a coin, like a coin pickup kind of game, and you're only ever going to have one coin. This is from like a tutorial example out on the web. You can make the coin a singleton. It's got a value of 1 point. You would just kind of have 500 references to this instance and change the XY coordinates of all the coins. You're always going to pick up 1 point every time you touch it, for instance. Yeah, stop using instance when I'm using the technical word instance so much. For example, there we go. But the key here is that, and why I'm kind of making this point, is that some people have thought that you could have like set methods inside the singleton, and there's not necessarily anything wrong with that. Like for instance here, for example, sorry, here, if we had private, or yeah, private int number of points or something like that, right? Let's say this is a coin. Then you could say set points to be 5 instead of 1. Now that would update every single coin to be 5 points. Maybe you got a multiplier and everything is worth double for the time being. That would technically be fine as long as you only ever have a single instance of this data object. But again, it's kind of debatable depending on your viewpoint with Singleton. Some people say it should never change once you instantiate it. Some people say, well, technically it's within the realm of reason. So just kind of a few things there for you to puzzle over and ponder. Nothing is strictly saying the internal data needs to be static, just the instance. All right, so let me pop over to a Python example here, and then I'll get you all working on your in-class assignment. So let's do this in Python, and again, just my preference. Software engineering is technically domain independent. So let me create some classes here. So class singleton instance equals none. So here is our internal reference to an instance. Now I'm going to add a static method here. And what this does, if I can hit enter correctly, def get instance. I've got my cheat sheet over here, so I'm not just coming off the top of my head with this. This basically allows us to call singleton.getInstance without actually instantiating the class. So if you're a Pythonista, normally you'd say, well, you need a self-reference in your parameters. If it's a static method, you do not. So if singleton.instance equals none, so it means it doesn't exist, then create singleton. Return singleton.instance. All right, so what have I done here? This is my getInstance function from Java, right? If there is no instance, create one, and then return it. This is the exact same code that we see. It gets higher and higher right here. Get instance. If instance equals none, create a new singleton, return the instance. Exact same code, just Pythonic. Right? So we have that there. Now, I would call get instance every time I want a reference to that later on. Now, I'm going to show you two things here. So the first is a fairly standard way of instantiating a class where I have an init method, right? So every time I call singleton, this init function will be called. Basically, this is your void main of a class creation. So here is our private-ish constructor. If singleton.instance is not equal to none, so meaning it's already been created, let's raise an exception. This class should be a singleton, you idiot. Don't you dare call me again. Rar. Perfect. So what does that mean? If I am trying to create a new singleton object, this assertion will be raised because there's already one in existence. So this is me telling other developers, never call this directly. It's possible in Python, at least the way I have it structured here. else singleton dot instance equals self. So let's create that instance, right? Now, this is all my classes. It basically looks identical to the Java one, except again, Python syntax. Let's use the standard main function call here. So that's your void main function for Python. S equals singleton. Print S. Okay, so this is me creating a new singleton and then printing out what it is. And what I'm going to get here is basically the string version of the Python object. And what it shows me is the hex value. So this is the memory blob, basically. Now what I can do too is let's say s2 equals singleton.getInstance. Print s2. s3 equals singleton.getInstance. Print s3. And get rid of the spacing here so that we can make things a wee bit bigger. That's right, this is so tiny. Terminal. Yeah, that's exactly what I want to do. Preferences are where in here? I'm still not used to VS Code. Pop, 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 pop. Preferences. Settings. Terminal size. Please be easy to find. You guys can squint. Haha. So, clear. Python 3 singleton. So when I print out the class references here, so S is the creator, S2 and S3 are calls to get instance, we see that these should all be exactly the same, right? Now, when I do this again, let's say S4 equals singleton. Print S4. So what I'm doing here and why this is different is that instead of calling get instance, which you should do for a singleton, I'm trying to create a new reference here. All right, so let's do this again, and I'm going to get my assertion error. Again, why did this happen? Because I tried reinstantiating it, even though very clearly I'm not supposed to do that. All right, so just call me X. Is that about what you did so far? Or should I call you X? When I was working, I was trying to get it to init. Okay. So that's going to be my second point here. So one of the issues that you might see is that creating a new instance is technically allowed in this particular setup. Right, so I'm going to leave the main code alone here. And let me actually delete or comment out this init code. Right, so one of the things with Python, I don't know, I'm going through puberty and my voice is going super high. It's just a day, I guess. Anytime you have a class and you add an init function, this is automatically going to be called and it's going to return a new class instance, right? So it's going to instantiate new memory. What you can do to get around this is instead of having an init function, let's create a reference to new. And let's call it CLS for class. And I pulled this, actually found this during the last class because I had the same problem. All right, so this is going to be called every time singleton is instantiated, basically. So if cls.instance equals none, cls.instance equals super singleton cls.new cls. Return cls.instance. I've never used the new function call before about 2 hours ago, so this was new to me. Haha. But basically, it's just a different way of kind of instantiating a class. And here we can be a little bit cute with our object-oriented paradigms here. So same function calls down here. When I run this again, now I have identical IDs. what I tried doing before, let me actually kind of flip back here. Let's comment this out. The cheeky thing you think you could do here is either pass, so don't do anything if there's no instance. If I do that, I'm going to get a different ID. Right, so it ends in BDA0, now it ends in BEB8. So clearly two separate instances, right? Maybe you think, oh, I can just do self.instance equals singleton.instance. You think that would work. But nope, you get a different ID again. Right, so here again, they end in different numbers, so different references. The problem again is how init returns things. Basically, you are instantiating it in memory regardless. But if you call it this way, and if you're interested, I've actually got a link here, which will explain things a little bit. We can kind of get around that memory instantiation. So now if we run this again, one more time, same reference, which ideally means life is good. What happens if you try to instantiate from another file by the singleton? You shouldn't have an issue with that. I'll try that last question out after class. Oh, I'm kind of interested because we have 20 minutes and this is, I believe, pretty much where I want it to end anyway. All right, yeah. So let me do that really quickly just for funsies. File, let's save as, because I've got, okay, good. Importer.py. I don't mind trying things out. Not sure if I'm lagging or the stream is. My connection seems okay, so I'm gonna guess, I'm hoping it's on your end. Let's see, from Singleton imports, Singleton. Make sure everything's okay. Python importer. No module named Singleton. Oops. This is lowercase. Hey there. Okay. Just making sure things are working all right. Now let's do this. Pop, 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 pop. I'm getting it too. Huh. Maybe it is me. GVSU. Yeah. All right. Okay, so it worked again, no problem. So I just imported the Singleton class from the other file. So hopefully it's just something maybe you typoed. But if you're having issues with different reference types, try this __ new syntax that I've got here, because this seems to actually be a little bit more intelligent. The thing I will mention, though, is that this is silently failing, right? So by having this kind of a method, you should not be doing this if you're a programmer, right? It should be very clear that you should be calling get instance. Otherwise, you're implying that you're creating a new instance every time. And you might understand that if it's just you and maybe your small team. But if you give this to somebody else, they might think they're creating a new instance of, say, Singleton, or whatever it's going to be called, when in reality you're referencing something that already exists. So you are silently failing, and we're avoiding that assertion error, but this is actually kind of promoting a bad programming practice in a way, because it gets the semantic intent hidden from the user. Make sense, though? So that's Singleton kind of in a nutshell. If you still are having issues with how it works, maybe you're getting different data types, ship me over your code. I'll take a look at it and see what I can find out. Maybe there's some simple explanation, but all the internal data should be the same. Alrighty, so now I'd like to do a little bit of an in-class activity to round out the day. I'm kind of curious what you all think, how you all think you might use Singleton in your projects. So what I'm looking for here is pop into your team Discord rooms, right? So some of you are in my Discord channel, some of you have your own thing. Anything's fine. basically come up with one pro and one con of implementing Singleton within your projects, your term projects. And I'll give you about 10 minutes to talk about this, and then put your response in CIS350 in section 1 in class discussion in my Discord channel. So let me bring that up here. Yeah, let's see that. Let's hide all my other folders that nobody cares about. So basically I have this 350 S1 in class discussion. Just copy and paste your answers in here and submit it to Blackboard so you can get some points for today. About 1:45, we'll talk about what you put in here. If you already have an answer, feel free to just drop it in and we'll talk about it as you go. And for what you have to add to Blackboard, let me show you very quickly. Make sure that people who joined late know that it exists. In 350, you have an in-class assignment, class sessions, UML design patterns, in-class assignment Singleton. Just submit your text that you put in the Discord channel and who worked on it, because it's basically whoever's here. Pretend like we're in class and I said, write down everybody's name on a sheet of paper and hand it in when you walk out. So is what I'm looking for clear, hopefully? One positive, one negative, how you would implement a Singleton, or how you could use it, and then one of the pros and cons for it. So I will let you all chat amongst yourselves for a bit. Put on some hot beats. This is my focus music. Yeah, I love Spotify ads. Let's not do Spotify ads. It's a silly thing. Let's find something on YouTube. All right, go forth and chat amongst yourselves. Dark synth, there we go. That'll work. Alright. Somebody pinged me. Yeah, let me, this is internal there. Alright, what are you all thinking? Not seeing any posts in the Discord channel yet, so... separate stuff. Sounded better in my head. It's Monday. Alright. Grading class called whenever an assignment needs to be graded. Processing power. I could see that. So you only ever have one instance of a grading class where... Yeah, it seems fair. Okay. Treat it like a prefab. If you have multiple enemies, you need multiple singletons, that's true. To Patrick, you could possibly have a complicated singleton, though, where it has everything in memory, and just based on how it's instantiated, you could get different data out of it. And like, you load in the entire tile map and yank out whatever parts you need. Or multiple singletons, that's fair too. Stuff happening in separate rooms. Okay, so yeah, I think you're all getting it, which is good. Hey, what's up, everyone? Ooh, by using singletons in your project, you start to create technical debt. I like that, Evan. Technical debt, that's a term I wasn't expecting to get into yet, but makes sense. Yes, use them carefully. You could honestly, technical debt, you could almost make an argument for any pattern. It's fair, I would say. not a bad vaporwave channel. What else do we got? Singleton to fetch different data from different servers. Create unnecessary dependencies. Who? Like that. Yeah, only one person. I'm answering too many questions. Alright. Good job, everybody. Evan, now we're gonna have to talk about technical debt. It's a fun term. Oops, not done yet. Fair enough. Difficult to test would need multiple items. Yep. Yeah, and the thing with multiple items is that there's nothing wrong from instantiating the memory-intensive stuff as a singleton and tracking the moving parts as like a logical object. That would save a ton of memory. Like load one tile set into memory, and then track all the various sprites or whatever as separate objects. Definitely one thing you can do. Singleton for menu pages. Oh, cool. Alright, well I think you're all getting the hang of it. Just wait for one more response to come in here. That's it? Okay. Well, I'm not going to hold you all too long, so make sure you get your submissions into Blackboard so that you can all get a handful of points for today. Always helpful to have more points. Other than that, look for the Blackboard announcement coming up, and I will see you all next time. Bye, everybody. Somebody is typing. Alright, well, I will end the stream. I'll see you all next time.